Hello. So, in the previous video, we talked about how to graph and then how to get an equation from that graph in order to explore the relationship between two variables. In that video, I did it by hand, drawing things out with the Expo markers. However, there is other tools that allow us to do that better. Today I'm going to show you how to do that using Excel. So, just like in the previous version, I started by making a table, I am going to do that here. So I am going to start by selecting the top of my table and inputting the title for that column. So I am going to write temperature, and I am going to put the units here, and that's going to be in degrees C. And the reason why I'm going to put the units there is because this is the title, and it's going to apply to all of the other entries in this column. So I've got that in degrees C, and then I am going to write next to it our pressure in atmospheres. Now, you notice that when I did that, I then lost my degrees C from the top of my first column. I can resize the column by putting the cursor in between the two and dragging. I can also auto size it by double clicking, just like that. And I can double click over here and it'll auto size for pressure. So now I'm going to put the temperatures in. So 25, 30, 40, 59, 92, 151, and 200. So I have just copied those numbers from my previous video. And if I was doing this for real rather than with numbers that I had made up a year ago, I would then have just gotten those from my lab experiment. You notice again that these numbers aren't evenly spaced. They don't have to be in an experiment because what we're after is the relationship between these two variables and the equation that shows that relationship. You also notice that I didn't put degrees C next to all of these, and the reason why I did that is because Excel needs to take a look at all of these as numbers. If you had degrees C next to it, Excel is going to interpret that as a word, and you cannot graph a word. So now let's look at pressure. So 1.0, 1.0, because it wasn't changing very much, 1.0, 1.1, 1.2, 1.4, and 1.6. And again, I just copied that from my previous video. So, still, this table doesn't really show very much. In order to understand what's going on, I need a graph. So in order to get a graph, what I'm going to do is I'm going to highlight those two columns and then go Insert, and I'm going to go, these are all my charts over here, and in physics, 99 times out of 100, the chart that you're going to use is a scatter plot, which is this icon right here, and if you go over it, the little helper text says XY scatter. So we can click on that and we can see all the various different scatter plots, all those different kinds of scatter plots. And the one that we want is this first one. We don't want any connected the dots kind of things. We don't want any extra lines on our graph yet. We just want a straight scatter plot. So we're going to click on that, and we see this comes up, which might look familiar, but this plot as it currently sits would not get you a grade that you would be particularly pleased with because nothing's currently labeled. So what we want to do is add all of the various different titles that we want. So up here is under quick layout, there's a bunch of different quick layouts that we could choose. Personally, my favorite to start with is this one right here, layout number 9, because it has the axes labels, and it'll automatically throw a line of best fit and display the equation. So all the things that we want to are right here in Layout 9. Now it also has a little bit extra over here. We don't really care about this key because we're having a relatively simple graph. So we can click that, and then I'm going to hit the delete button in order to get rid of it. And this even allows us to see the graph better. So now we have a spot for our title, our spot for our axes titles. So we can change this title, which it just stole from over here. So it's a boring title. The title that I used in the last video was How Temperature Affects Pressure. And I did a better job of spelling it here than I did there. That should probably be capitalized. All right, so now we also have to name our axes. So this axis right here is going to be called temperature. And that's going to again be in degrees C. And then this over here is going to be atmospheres. Or rather, it's going to be pressure measured in atmospheres. And I can now click that to get rid of it. So now we're doing pretty good. We have both of our axes starting at 0, 0. If you need to manually go in and change your axis scale, you can click right here, specifically right click and go to Format Axis. And under Axes Options, you can see minimum. You would want to make sure that that's 0, and maximum, the auto for maximum usually is pretty good, but you can also set that. You can also set up how much ticks you want, but usually auto is pretty good. The only thing auto really screws up a lot of time is setting that minimum value. Same thing with my x-axis. We're looking pretty good. Now, right here with our equation, we can drag that around just like what I did, but y and x really don't explain what's going on. And also, this is one of those where we got numbers here, and all the numbers need units. While I'm talking about this, before I go and fix it, you also see this r squared value. That r squared stands for root mean squared. It is a measure of how good the fit is. In physics, usually we have values that are very, very high for our r squared because the math that we apply to it matches our data very closely. So this is one of those where if you end up with an r squared that's lower, chances are you might need to do something else to your data to make it fit better, and I will explain that in a later video on linearizing graphs. So 0.994, we're good with that. We really don't need that information anymore, so I'm going to delete that. So y, what does y represent? That's going to be pressure. And then we have our slope. So that's the 0.0035, but that needs units. So I'm going to, because this is units of slope, so rise over run, I'm going to have my units of rise, so atmospheres, over my units of run, which is degrees C. And then x. What's x? X in this case is the temperature. So I am going to put my temperature right there. And then I need to also have units attached to my y-intercept. So the units for my y-intercept is going to be atmospheres. There shouldn't be an S on atmospheres. The only other thing that we could do at this point is to make sure that we don't have too many significant digits on our numbers, so we can go through and delete like 2 of them right there. So this now looks real nice. I would say we now have a completed graph that has now calculated our line of best fit for us. All we had to do is go back and clean it up just a little bit. Thank you very much for watching, and have yourself the most wonderful of days.